Today, we have two main goals. First, we'll introduce some terminology and concepts that will be helpful as we investigate validity. And second, we'll begin to discuss what it means to develop a formal method for assessing the validity of arguments. Specifically, we'll begin to think about how we might come to appreciate the form of an argument so that we might assess its validity without worrying about the actual truth or falsity of the premises that compose it. In other words, we're going to be developing our formal methods that we talked about on our first day to look at the structure or the form of arguments. I want to start today by talking about some logical properties of sentences. The properties we're going to talk about are the property of being necessary, the property of being impossible, and the property of being contingent. Some sentences are necessarily true. They can't possibly be false. Either grass is green or grass isn't green. We can certainly imagine that grass is not the way it appears to us. Maybe grass could have been blue. But in that case, grass wouldn't have been green. Grass either has to be green or not green. Another sentence that's necessarily true. Jeff isn't both taller than Biff and shorter than Biff. There's no way this sentence can be false. It's necessarily true. We'll call sentences like these logical truths or tautologies, and we'll refer to them as being necessary. Another class of sentences are what we might call necessarily false. They can't possibly be true. They are impossibilities. For example, this sentence is both true and false. It is not possible for a sentence to be both true and false. It's either one or the other. So this sentence is necessarily false. Another example. Lily Briscoe sat by the ocean, and Lily Briscoe never sat down. If Lily Briscoe sat by the ocean, then she sat down at some point. So therefore, this sentence is necessarily false. It's an impossibility. We'll call sentences like these contradictions, typically, though we might also talk about them as being impossibilities. A third class of sentences are sentences that are neither necessarily true nor contradictory. That is, they can be true or false. The Brewers won a game yesterday. Right now, the baseball season isn't going, so this sentence is false, but later in the year, this sentence may be true. More people live in Chicago than live in Houston. At certain times in America's history, this sentence has been true. At other times, it may be false. We'll call sentences like these contingent sentences. These are sentences that are capable of being true or false. Every sentence is in one and only one of these three categories. All right. Just as we can talk about the properties of a single sentence, we can also talk about relations that hold between sentences. And one of those relations is the relationship of equivalency. So consider these two sentences. Reginald Dufree III lives in the house directly east of Lucky Pellebon. Sentence 2. Lucky Pellebon lives in the house directly to the west of Reginald Dufree III. Now, both of these sentences are contingent. We don't even know who Lucky Pellebon is, much less whether or not he lives next to Reginald Dufree III. Furthermore, sentences 1 and 2 don't quite mean the same thing. However, if one of the sentences is true, then they both are. And vice versa. If one is false, then they both are. Two sentences are said to be logically equivalent if and only if they have the same truth value as one another in each and every possible situation. In any situation in which Reginald Dufree III lives in the house directly east of Lucky Pellebon, then Lucky Pellebon will live in the house directly west of Reginald Dufree III. This depends on the relationship between the predicates living east of and living west of. These sentences are logically equivalent. They always have the same truth value. For equivalent sentences like these, they have the same truth value as one another in each and every possible situation. If that's the case, then it's not possible for one of them to be true without the other being true. According to our definition of validity, then, an argument from 1 to 2, or from 2 to 1 for that matter, is a valid argument. It's not possible for a premise, let's take sentence 1 as the premise, it's not possible for that sentence to be true while the second sentence, sentence 2, considering it as the conclusion, is false. In other words, if the premise is true, the conclusion must be true. And this goes whichever way these two sentences are related to one another. If 2 is the premise, then 1 has to follow from that. So we'll generalize this point by saying that if two sentences are equivalent, then an argument with either one as the premise and the other as the conclusion will be valid. Now let's look at two other ways in which sentences might be related to one another. Consider these sentences. The chairman of the board is richer than the chief executive officer. Sentence 2. The chairman of the board is poorer than the chief executive officer. Now, logic alone can't tell us which, if either of these sentences is true. Maybe in some corporations who have a chairman of the board and a chief executive officer, the chairman is richer and the officer is poorer. Or maybe in some situations it's the reverse. Logic can't tell us which of these holds for any of these sentences. But we can say that if one is true, then 2 must be false. And if 2 is true, then 1 must be false. Two sentences are said to be inconsistent if and only if it is possible for them both to be true at the same time. But if they can both be true at the same time, then they are consistent. So consistent sentences are ones that can both be true at the same time. Inconsistent sentences are ones that cannot be true at the same time. Note, since any necessary truth is true in every instance, any pair of necessary truths is consistent. I leave it to you to think about whether any pair of necessary truths is equivalent. That would be to say something more, but think about whether or not that holds. Just as we can talk about a pair of sentences as being inconsistent or consistent with one another, we can also talk about a group of sentences as being mutually inconsistent or mutually consistent. So consider these sentences. The chairman of the board is richer than the chief executive officer. The chairman of the board is poorer than the chief financial officer. The chief financial officer is poorer than the vice president. The vice president is poorer than the chief executive officer. Consider these relationships for a minute and think about where the inconsistency lies in these 4 claims. Notice that no 2 of these sentences are inconsistent with one another, nor are any 3. If you took any 3 of these sentences, they all fit together. They're all consistent. The chairman of the board may be richer than the CEO, while the chairman of the board is poorer than the CFO. The chief financial officer, the CFO, on the other hand, may still be poorer than the vice president. All 3 of those can be true. That poses no problem. However, these 4 sentences are jointly inconsistent. They can't all be true at the same time. If the chairman is poorer than the CFO, and the CFO is poorer than the VP, and the VP is poorer than the CEO, then given that the poorer than relation is a transitive one, and we'll talk about what that means later, the chairman must be poorer than the CEO. But sentence 1 entails that the chairman is not poorer than the CEO, since it says he's richer than him. So these 4 sentences can't all fit together. 1 through 4 is what we will call an inconsistent set of sentences. Let's set aside our consideration of the logical properties of sentences to return to our considerations of formal languages discussed at the beginning of this term. We're now in a position to appreciate how formal languages can be of use to us in assessing arguments. So what I want you to do is consider these two arguments. These arguments are very similar, but they have some important differences. Here's the first argument. Premise 1, Houston is in Texas or Houston is in Wisconsin. Premise 2, it's not the case that Houston is in Wisconsin. Conclusion, so Houston is in Texas. Now here's the next argument. Premise 1, Houston is in California or Houston is in Wisconsin. It's not the case that Houston is in Wisconsin, so conclusion, Houston is in California. Now notice, the first argument is good in two ways. It's valid and it has true premises. It's sound, in other words. The second argument, on the other hand, though valid, does not have all true premises. Premise 1 is false, and therefore, so is the conclusion. But how can we appreciate the underlying form or structure that these arguments have in common that leads them both to be valid without getting hung up on the actual falsity of some of the premises in argument 2? Recall the other day when we talked about validity, we had trouble moving away from the actual truth and falsity of sentences to determine what would be the case were those sentences true. Well, I think when it comes to appreciating what the arguments have in common, we should recognize that not only are the two arguments valid, but that they're both valid in the same way. They both have the same form or the same underlying structure. But how can we appreciate the underlying form that these arguments share while extracting away from the falseness of a few of the premises in the second argument? Well, the way we can do that is by using formal languages. In this course, we'll be developing a language that will allow us to appreciate the underlying formal or structural properties of arguments. And for this reason, we'll call this a formal language. We can state arguments in the formal language we'll develop, or we can state them in more natural languages, such as English, as we've been doing so far this term. But whereas our formal language is precise, natural languages are vague and messy. So as we move into introducing our formal languages, I want you to bear in mind that our translations from English into our formal languages will not always be exactly the same as one another. The English language statement of the argument may seem slightly different, but when we construct the same argument using our formal resources, we're trying to capture the important logical properties. So that's an important thing to bear in mind as we go forward. The fact is that in constructing a formal language, we face a tension between the desire to capture as much of the structure of English as possible and the desire for a simple language with tractable rules of inference. We'll spend a lot of time talking about the similarities and differences between our formal language and natural languages like English, and this is just something I want you to flag. But for now, we're going to move into starting to look at the pieces, the different properties of our formal language that will allow us to appreciate the underlying structure of arguments and their validity. The first concept in our formal languages that we're going to introduce, which will help us appreciate the underlying structure of arguments, is sentence letters. Now, recall the two arguments that we discussed earlier, which were valid in the same way, even though one of them was false. How can we appreciate the underlying form that these two arguments share while abstracting away from the fact that the second argument contains a false premise and therefore isn't sound? Again, the other day we got hung up on the actual truth or falsity of sentences while not appreciating what would be the case if the sentences were true. Sentence letters are going to help us get away from the actual truth or falsity of the sentences and see the underlying form that the validity of the argument rests on. Okay, well again, the idea is to get a sense of what the structure of these two arguments are. We want to abstract away, in other words, from the meaning of the sentences that make up these sentences to appreciate what the underlying syntactic structure is of the argument share. So, one thing that we might notice here is that these arguments have a couple of basic elements, basic sentences that make up the respective premises and conclusions that compose these arguments. So here are the basic sentences. So the first argument, the argument on the left, consists of the following sentences. Houston is in Texas, or, and we'll ignore the or there. So the sentences again are Houston is in Texas and Houston is in Wisconsin, right? These are the smallest elements of this argument that can be true or false, right? The smallest elements that can be true or false in their own right. And of course, they go to make up these larger sentences with these additional elements, or, and it's not the case that. But still, these are the smallest elements that can be true or false. In the second argument, it has a similar kind of structure in that it consists of two small sentences combined together with a logical element. So in the first one of these sentences is Houston is in California, and the other is Houston is in Wisconsin. So maybe we can stop focusing on whether the premises of these arguments actually are true and focus instead on what would happen if they were true by substituting in some variables to stand for these basic sentences. Maybe that will allow us to see the underlying structure that these arguments have in common. And so let's try that. So here's what we're going to do. On the sentence on the left, we're going to let A stand for Houston is in Texas, and we're going to let B stand for Houston is in Wisconsin. In the sentence on the right, we're going to reuse one of these letters. We're going to reuse A, and we're going to let A stand for Houston is in California. And then we're also going to let B stand for Houston is in Wisconsin. So if these variables, A and B, stand for the same basic sentences, the respective basic sentences in our two arguments, then we can substitute these variables into the sentences and represent the two arguments as follows. So again, the sentence on the left, we replace Houston is in Texas with A, and Houston is in Wisconsin with B, and so we get A or B. It's not the case that B, so A. And for the argument on the right, we replace Houston is in California with A, and again, Houston is in Wisconsin with B, and so we get A or B. It's not the case that B, so A. And so now it's clear how these two arguments share an underlying formal structure with one another. So sentence letters are what we're going to call these variables that we've just introduced. Sentence letters stand for sentences. And we'll call the basic sentences that they stand in for atomic sentences, because just like atoms, these are the basic building blocks of our sentences. In other words, just like atoms are the basic building blocks of molecules, atomic sentences are the basic building blocks of complex sentences. So isolating and abstracting away from these atomic sentences using sentence letters allows us to appreciate the form of many arguments. And finally, we'll call the logical language, which treats atomic sentences as the basic building blocks of arguments and replaces them with sentence letters to appreciate underlying form, sentential logic. And this will be what we will be studying before the midterm reading period. After midterm, we'll turn to predicate logic, which is a bit different. That's all. Thank you.